Exponent rules. Exponent rules. Exponent rules give us a quick way to multiply and divide variable expressions. For some of the rules, we will work through and discover them. For some, we'll just look at examples. Let's look at this first example, x cubed times x squared, and try to figure out the rule for multiplying variables. If we write out what x cubed means, it is x times x times x. And we have multiplication in between. If we write out what x squared means, it is x times x. Now, if we put this back into exponential notation, x is our base, and we have 1, 2, 3, 4, 5 copies, so 5 will be our exponent. Our situation is that we had like bases, we had both x, and it is a multiplication problem. So like bases multiply, we're going to keep the base and add the exponents. The 3 plus 2 gives 5. So keep the base, add the exponents. Let's look at another example. X cubed times x. If we write out what it means, x cubed is x times x times x, and then we have another x all multiplied. So if we go to exponential form here, we have one base, which is x, so we keep the base, and we have 1, 2, 3, 4 copies of the x, so our exponent is a 4. So when you're adding the exponents, if you don't see an exponent, remember to add a 1. So we have to do 3 plus 1 to get 4. Let's look at another example. 2 to the third times 2 to the fourth. A long time ago, we learned to do this problem with order of operations. And so we would do the exponents first, and then we would do a multiplication. But it is set up so that we could use exponent rules because we have the right situation. We have like bases, the base is 2 for both, and it is a multiplication problem. So our rule says keep the base and add the exponents. So 3 plus 4 is 7. Let's look at one more example. This problem looks quite a bit longer. What we want to notice is that it is multiplication between the parentheses, and it is all multiplication on the inside of the parentheses. So we can use the associative law of multiplication to rearrange it. If you only have multiplication, your order doesn't matter. So I'm going to pull my numbers. So -5 times 3, and then my x's, x cubed times x to the fourth, and then my y's, y squared times y. So I'm just putting the things that are alike together. And now I'll go across. So for my numbers, I'm going to do plain old multiplication. You only have one negative, that's odd, so it's -15. For my x's, you have like bases multiplied. Keep the base, add the exponents. For the y's, same situation, like bases multiplied. Keep the base, add the exponents. You have to remember to add the 1 for this y. So 2 plus 1 is 3. Our next exponent rule that we'll look at is called the power rule. Let's look at this example and try to figure out the exponent rule for this situation. So we have a base to a power, and the entire thing is raised to a power. If we write it out for the outside exponent, it says 2 copies of everything inside. So we would have x to the fourth times x to the fourth. If we use our rule we learned earlier, which is like bases multiplied, keep the base and add, we would figure out that we have x to the 8th. Or if we didn't know that rule, we could write it all the way out. X to the 4th is 4 x's. And x to the 4th is 4 more x's. And if you go back to exponential form, you have 8 x's, which gives you the x to the 8th. So if we're looking just at our original problem and trying to get the rule with our exponents, when we have one power raised up to another power, they're going to multiply. So our rule here with one power to a power is keep the base and multiply on the exponents. So to write out our rule, if we have a power to a power, so we only had one base in this problem, to a power, the entire thing is to a power. So we'll call it a power to a power. We keep the base, so we kept the x, and we multiply on the exponents. Let's look at another example. So we have x squared to the 5th power. So it is a power to a power. We only have one base to a power. It's raised to another power. So this is the situation of a power to a power. We're going to keep the base and multiply the exponents. So 2 times 5 gives us 10. Exponent rules, the power of a product rule. Our situation in this example is that we have a product to a power. It is important that it's multiplication inside. And so we're going to apply that outside exponent to each piece. If we wrote it out, it would be 3 copies of the whole thing. Instead, we'll just apply the 3, take it down to each factor of the product, and that will do the same thing as writing it out 3 times. So 3 of each of those. So we'll have 2 to the 3rd, x to the 4th to the 3rd, and y squared to the 3rd. And now we'll simplify each of these pieces. 2 to the 3rd will actually be 2 times 2 times 2, which gives us an 8. The next one, x to the 4th to the 3rd, actually kicks back into our last rule. We have a power to a power. Remember, keep the base and multiply. So that's going to give us x to the 12th. Same thing for the y's. Keep the base and multiply on the exponents. But notice for the 2 to the 3rd, the 2 actually just raised to the 3rd power. It was not an exponent to an exponent. It was just a base to a power. That power to a power is for an exponent to a power. Let's look at another example. Again, we have a product. It's all multiplication inside to a power. So we're going to take the outside exponent down and distribute it to each piece. So we will have -4 to the 2nd power. We will need to use parentheses because the negative is on the inside of the parentheses originally. So we will need to keep it inside parentheses, so it will go to the power. We have x to the 7th to the 2nd power, and y to the 5th to the 2nd power. Remember, the number will actually raise to the power. So it's negative 4 times negative 4 will give you a positive 16 because you have two negatives. For the variable, it is a power to a power. So you're going to keep the base and multiply the exponents. Same thing for the y. Keep the base and multiply on the exponents. Let's look at one more example. This problem is going to have a combination of our three rules we've looked at so far. So when we look at it, we're going to have to simplify each set of parentheses separately and then work with the whole problem. So we'll just concentrate on the first one, a product to a power. The 3 will apply to each piece inside. And so we'll have a negative 2 to the third power, x to the 8th to the third power, and y cubed to the third power. Now let's work those out. Remember, the negative goes to the power, so negative 2 times negative 2 times negative 2 will give you a negative 8 because you have an odd number of negatives. For your variable, a power to a power, keep the base and multiply on the exponents. So 8 times 3 is 24. For the y, also keep the base and multiply on the exponents. 3 times 3 is 9. Now let's look back at our problem. Notice your parentheses are side by side. Remember, that means multiplication. So we're going to have a multiplication in here, and we also had it here. Then we'll go to the second set of parentheses. That is a product to a power. So we're going to take the power down to each piece. So apply the 2. So we will have 5 to the second power, x to the 4th to the second power, and y to the second power. You didn't have to write this one in parentheses. It's really y to the first to the second power, which they would multiply, and it's still going to give you 2. So you can actually just go ahead and put the 2 on the y. Now we'll work these out. 5 squared is 5 times 5 is 25. For the variable, keep the base and multiply. So 4 times 2 gives us 8. And the y is already worked out. Now let's look at the problem we have. Everything is all straight across, so they're all multiplied. For multiplication, remember, you can change the order because of the associative law of multiplication. So I'm going to rearrange it. I'm going to move my numbers and put them together. So negative 8 times 25. Then I'm going to put my x's, x to the 24th times x to the 8th. And my y's, y to the 9th times y squared. For your numbers, we're going to do a regular multiplication. It will be negative because we only have one negative. 8 times 25 will give us 200. For your x's, now we're back to our very first rule. We have like bases side by side. Your rule is keep the base and add on the exponents. So we're going to keep the x, add the exponents, will give us a 32. And for the y's, we will keep the base and add the exponents.